This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Hello, this is Tobias for Software Engineering Radio. In this episode, I am talking to the CTO and founder of LucidWorks, Grant Ingersoll. As you know from earlier episodes, he is connected to Apache projects like Lucene, Solar, and Mahout. Together with Thomas Morton and Andrew Ferris, Grant wrote a book entitled Taming Text: How to Find, Organize, and Manipulate It. And almost 1 year after being published, I will talk with him about the book and its influence on the community on this show. Grant, thanks for being on the show.
Thank you. I'm glad to be here again.
I think you have heard of the Turing test being passed in June 2014. And for our listeners, there was this guy called Eugene Goostman who passed the Turing test, who was just chatting around with people from all over the world. But in the end, it was a chatbot and not a real person. And so that was kind of the core of the Turing test. And I think you should have been partying after hearing this. Or what were your thoughts? What were your reactions on this Turing test?
Yeah, no, that's it's interesting. I should have been partying. I think it's obviously a great advancement, and I think it speaks to a lot of the effort that has been going into artificial intelligence, machine learning, natural language processing. A lot of the things obviously I'm trying to cover in my book. I don't think the stuff in the book, quite passes the Turing test yet, but I do think it kind of lays the foundation for a lot of those things. And so, I think it's a great advancement. Obviously, there's I think still a long ways to go in terms of being general purpose enough to handle all language in all situations, but it's really a good step in the right direction.
Were there any products you are involved in part of the solution? Do you know any particular stuff there?
No, I'm not actually familiar at the low level with what they did. So, but I would imagine it's, a good chunk of open source along with some of their own mixed in kind of things. So,
yeah, let's hope it gets back to the open source community then, so everyone can learn from it and use the libraries. But then let's get to the core meaning of this show, which is talking about your book, Taming Text, which has been released at the end of last year, if I'm correct. And I know that you are actually working on a second version right now. Is that correct, or is it wrong by now?
I know we are slowly working on a second version. As you listeners of this show may know, I'm also involved in a startup. So as always, writing a book is a long and laborious process, but yeah, we are writing a second edition, although the first edition continues to do well and continue to get good feedback there. And I think while some of the examples are going to be updated, the core concepts are still really solid in the first edition.
Okay, yeah, we'll be going back to this in a couple of minutes. Before that, I'd like to ask you, why did you actually write the book? What was the reason? Why did you get to the topic of taming text, of processing text, and to writing a book about that?
Yeah, that's a great question. There's actually, I think, kind of two levels. One, it's the book I wish I had when I started, or at least it's an attempt at the book I wish I had when I started, which is, my target audience and our target audience with Taming Text was really developers who, that you're a good programmer, but aren't necessarily familiar with search and natural language processing and programming. And so you wanted something that could help you get going on the examples, the concepts, the ideas, also leveraging a lot of the strong open source capabilities out there. And really, to be honest, without the, the math and the kind of the dense academic rigor that a lot of the books in this field have, because frankly, I think a lot of engineers simply don't have time to dig into all the formulas because, let's face it, they've got problems they want to solve, and so they want realistic ways to get those done, not necessarily worried at first about the theory behind it. They would rather go and explore it. Second, it was just thinking. The second area kind of is obviously a bit more personal, but career-wise, I was looking for something to help help me along on my career. And frankly, I think having a book, writing a book can be something that can help boost your career and your standing in the community and things like that. And so, it's definitely been very helpful for my career as well.
But a big effort, I think, to boost your career, since I think I couldn't manage to write a book about anything in the end.
Yeah, no, I mean, you'd be surprised. First off, there's a real thirst for technical books. I think the publishers of technical books are always looking for authors. So it is definitely a labor of love, as they say. It's not something that you make money off of directly, although, obviously I have received some royalties for it. But it's not like you're writing the great American novel or the next New York Times bestseller here. And so you very much have to go into it as this is something I love to do or I want to do. And then, it is hard. You've got to put in a lot of time into it, and you've got to figure out how to speak to users in a way that they're readers in a way that they're going to understand. I don't, obviously the public can judge that. I think we did a good job at it, but, ultimately other people are the judge of that.
Yes, for sure. Based on the feedback, what are your listeners actually working on? Or to put it in another phrase, why are they buying your book and reading it?
Yeah, I mean, I think, as I mentioned, I think the readers are definitely engineers. They're often Java programmers. They're getting started in this field. I see this time and time again at LucidWorks, my company, where we go into an organization, we're helping them with a lot of these issues like search, machine learning, natural language processing. There's usually one or two people there, often the boss or a PhD or somebody who's really experienced in the field who knows search and all of that. And then they've got a bunch of other engineers who are good, strong programmers, but just getting started with these particular kinds of problems. And so they're buying it because it helps them get up that learning curve. As I mentioned earlier, it is not a book for experts. It's very much a book for beginners, or mid-level people, or people who want to have deeper knowledge on some of the open source libraries that we cover. And so I think a lot of the feedback we get is along those lines. Hey, great book for helping me get started. Meanwhile, the experts are saying, yeah, I already knew that, which is fine. That tells me we hit our target audience right on.
That's good. Do you also hear phrases like, well, we will buy a Google Blade and that's it for us? And what are your thoughts about that?
So like the Google search appliance?
Yes.
You mean? There's a time and a place for that. Obviously, I think that's much more of a black box situation. It's, really set up and designed for kind of low end search around, your corporate intranet. We see time and time again, the reason why people are selecting technologies like Solar and Lucene and OpenNLP and Mahout and others is they have a problem that's much harder to solve. They have a problem that they want to have control over. They want to know how the inner workings happen. They want to be able to control those inner workings, alter those inner workings. They also want to be able to more effectively monetize or more efficiently deal with their data. So, a black box doesn't do that for you. Whereas when you've got open source, it's essentially the ultimate white box, right? And so I can dig in if I need to, but I don't have to. And so, it really helps them solve much harder problems that I don't think you can with just a black box type approach.
Can you give at least one example of this kind of problems they want to solve, which is not simply searching your intranet or other easy data files or whatever?
I think there's lots of great examples out there. E-commerce is probably one of the strongest ones where, there are so many signals coming in from your users, your buyers, the general web, public, all of that kind of stuff that you want to then incorporate into the way you return search results. So, if somebody comes in and searches for TVs, you want to be able to rank those results according to lots of different criteria that goes well beyond just, hey, does the word TV match? I remember a few years back, one of our customers who was on public record was Sheet Music Plus. They're, I think, one of the world's largest purveyors of sheet music, ranging from modern rock and roll all the way back to Beethoven, Bach, etc. And when one of their top queries against their search index was simply the word piano. Now, you tell me, what should I return for search results when somebody types in the word piano? It's usually quite straightforward if they type in, Beethoven's Ninth Symphony and whatever, for harpsichord or whatever it is, right? But if somebody just types in piano, what should I return? And so what companies like that want to be able to do is leverage all of these different factors, these features, signals, if you will, that help them figure out what they should return. Because in fact, users time and time again are telling them what they want to see when they search for piano. They want to see the most popular piano items. Maybe the company wants to overlay in that the items that they make the most money on, et cetera, et cetera. And so all of those things factor in to an overall ranking that they want to be able to control and manipulate so that they can ultimately keep their users happy, as well as obviously increase their profits.
Yes, understood. Getting back to your book, Taming Text, what tools do you use to tame text in the book and maybe in your real life as well? And why are you choosing exactly those tools?
I think the tools people are using, first off, the book is really geared towards each chapter presents a concept like search or named entity recognition or clustering, and lays out the concepts behind those in layman's terms or engineering terms at least. And then we go into an example of some open source that helps solve those problems. So for search, we use Lucene and Solr. For clustering and some classification problems, we use Mahout and a few other libraries. For things like string matching, we actually roll some of our own examples. But primarily speaking, we chose open source libraries that have commercially friendly licenses, like the Apache license or the BSD license, things like that. And there also just happen to be projects that we think are pretty popular, and also projects we're intimately familiar with. So, Lucene, Solr, Mahout, OpenNLP, and then a few others coming on in the new version. The second version will also be added in there as well. So, I tend to use in my day-to-day job a lot of Lucene and Solr. I also use a variety of open source natural language processing tools, and then supplement that with stuff that we build ourselves.
Your book elaborates a lot about search engines and their use and how to adjust them. So I'd like to ask you the question, how do those search engines actually judge or adjust the quality of their results? Is there a difference between multi-purpose search engines and single-purpose search engines? And are there some different approaches in there?
Yeah, no, that's a great question. I mean, I think, obviously I can't speak to, how Google or some of the large engines, they don't reveal all of their secret sauce. But, generally speaking, the way, there's a couple of different approaches to determining whether a document is relevant or not. And then, of course, once you determine if something's relevant or not, then it's just simply a matter of taking that score and sorting by that such that you return out a ranked list of results. The main two ways, one is a probabilistic way, which is essentially saying what is the probability that this document answers this query. And there's other, you can actually flip that on its head and say, what is the probability that this query matches this document? And so there's different approaches to that, and there's a couple of different open source engines out there that support those, including Lucene. The other one, and often the more commonly implemented one, is what's called the vector space model. And if you think back to your high school mathematics classes, you can essentially think of the vector space model as you've got a vector representing the document in an n-dimensional space, and then you've got a vector representing the query in that same n-dimensional space. If you put their tails together, that forms an angle. If you take the cosine of that angle, you get a score between -1 and 1. And so if you remember your math again correctly, when the angle is 0, the cosine is 1. And so intuitively speaking, you would think that since those two vectors are exactly the same, they should be a very high match. In reality, we take that model and modify it. We add Boolean logic on top of it. We add lots of other scoring factors that you can bring into play to essentially help you do that ranking. And then what is often done is you have data sets that you quote unquote practice against that allows you to determine whether your rankings are good enough or not. And then you may actually have rules that you overlay on top of that too. And big companies like Google and the like, I mean, they have hundreds, if not thousands, of people who work on and manipulate those rankings throughout the day, throughout the year, such that they're trying to improve that user feedback loop, if you will.
So they are actually doing some sort of A/B test here and say, okay, this and that changed, and this is a good result or a bad result, or how are they actually doing it?
Yeah, actually A, B, C, D, E, F, G, all the way
Okay.
through Z. I mean, I think from what I've seen and understand, the large majority of users in internet search engines are in an experiment at any given point in time. And so actually, a small percentage I don't know what the exact numbers are here. I've heard, that it's roughly 10% of users see what is considered to be the best version of that internet search engine at any given point in time, and everybody else is in an experiment. And those experiments may be anything ranging from changing the color of an icon to changing the font to changing the actual scoring algorithm. And so they're constantly looking for ways to tweak the search results. And ultimately they're looking for ways to balance and increase the amount of ads clicked relative to the results that they're displaying, right? So obviously they have different goals than just necessarily providing you with the absolute best results that answer your question. They also want to make sure they want to increase the likelihood that you're going to click on an ad as well, right? So, there's lots of things that go into calculating that. But yeah, at the end of the day, we're all in a big experiment.
All right. And how important is the actual position or rank of an item within the result set? And is there a difference between general purpose search engines like Google or Bing and special systems for a certain user group, for instance, scientists or so?
Yeah, I mean, I think, I cover this a fair bit in the search chapter of the book, but I mean, I think it really, the answer is it depends, not to cop out, but, there's been a lot of academic study of this. And I think at the end of the day, it depends on the user and what the user is expecting. I think often the reason why search engines fail is they fail to capture what a user really wants or needs. And so, that understanding comes from thinking about who your user is, right? So if I'm, Joe consumer on the internet and I'm just looking for a TV or something like that, then, they're if they just put in a generic term, then, they're probably not going to be too upset if the TV they actually end up buying is in the fifth slot as opposed to the first slot, or even perhaps on the second page, although that's not as likely. But if they put in a very specific kind of TV, with very specific attributes, they want a 57-inch Sony, whatever, with, 3D hologram projections, right? And that one, they know it exists and it doesn't come up, then they're going to be upset, right? And perhaps go look elsewhere. Similarly, if you're working for a competitive intelligence situation, or if you're trying to find terrorists or other bad guys, your criteria for the results is often very different because you're obviously invested very deeply in making sure you find that needle in the haystack. So you're often willing to read a lot more results. You're often willing to spend a lot more time adjusting your queries and tinkering with the way you look at the results so that you can try to find that, proverbial needle in the haystack that, helps you catch the bad guy or prevent something bad from happening, right?
Yeah. And just because I'm a bit related to it and things like e-discovery, it's kind of the same. You're just not allowed to have something being lost.
Yeah, I mean, if you think about it like e-discovery or legal situations, like if you hand over a bunch of emails that you didn't know talked about, a company doing something bad, and then you hand that over to the prosecution or the other side, that's the smoking gun, right? And so then you're going to be in big trouble.
That's right. Yeah. You don't want to do this. Kids need to learn to understand texts while growing up, and machines too, of course. But is it the goal to actually preserve the computer's state of mind, or to enable every machine to build up the database and learn again? So, or is there something in between?
Well, I mean, I think if the computer is learning a model, you certainly would behoove you to not forget the model unless you decide that that model is just not a very good one. So, there are systems that kind of take a genetic or an evolutionary approach to learning. And so they throw away old models that aren't deemed as good as newer models. But, that's still different. They'll still keep the model they have, that, if they were to shut down or restart, they would still have that model preserved. There's also obviously, kind of the bootstrapping problem one would face when going into a new environment. So, if you've trained it on a certain model and then you've deployed it into a situation where it's capable of learning, but, that original model is not very good, you obviously would end up, either right away or as you learn more, throw out that older model or at least adapt that model. But I'm not as familiar with ones that, just lose their, in-memory state and then have to rebootstrap themselves the next time they come up. I mean, that doesn't strike me as necessarily a good approach, but maybe I'm missing something there.
Okay, it might be because I'm thinking of systems that replicate themselves and just have a small amount of data, but need to actually be precise in their results.
Yeah, I mean, I think that's one of the benefits of, I mean, especially if you're comparing it to people, right? I mean, in theory, the replication of knowledge on a computer is, significantly faster than it is in the human race, right? I mean, I think takes us years and years to learn, for kids to become on par in intelligence with adults, right? Whereas, presumably once a computer has learned something, if it truly is learning in the same sense, we can then clone it quite quickly because it's all digital and electronic. I mean, I think perhaps what you're getting at too is a lot of times, you're obviously you're building a model, right? And so that model is a representation of the raw data or the data that it's seen so far. And so that model often ends up being obviously a lot smaller than the original data. And so then, we can go and replicate that model across lots of machines, right? And so in some regards there, each machine has a base starting model that it can come from, and then it learns new based off of what it sees, right? And then sometimes you'll have algorithms that actually sync them back up and figure out which one's the most efficient one. That's kind of where that evolutionary approach I talked about earlier can come in. So and then there's also a lot of work being done these days on what's quote unquote called deep learning. And so, that can also that's all about just bootstrapping from very little training, if you will, just bootstrapping from, what it sees and trying to figure out the relationships without actually having somebody tell it what the relationships are.
Getting into some more advanced and maybe real life aspects of in inverted commas, taming text now, I'd like to get to some chapters of your book. The first one is fuzzy string matching. What is fuzzy string matching, and why is this important for our day-to-day search life?
Yeah, that's a great question. I mean, this is actually one of the chapters we debated as to whether, quite heavily debated as whether it belonged in the book or not. And ultimately, obviously, we decided it did. I think, string matching, just straight up matching, two words that are equal or not is obviously pretty well understood and is a rather simple function on, in Java, like a string object, or in C or whatever, right? And that's all well and good for when you have exact matches. But as we all know, the world is not exact. And so there's often fuzziness. People misspell things. People make all kinds of errors. You have problems like if you're scanning in image, documents, and then you do OCR, the OCR process can be noisy. And so there's just all these places and times where text is fuzzy, for lack of a better word. Like we just don't know whether it exactly matches. And so we need algorithms that help us deal with that situation, right? And so that particular chapter helps users understand different algorithms for calculating how similar individual words are, individual strings are, and then using those judgments to then, kind of seed the rest of the techniques in the book, right? So if if you say, for instance, you're dealing with certain kinds of users who always misspell your last name or misspell the name of your product. For instance, a classic one is that people spell iPod like they'll spell it I space pod, they'll spell it I dash pod, spell it I capital P O D, et cetera, et cetera. And so at the end of the day, you still want to match what they're after, which is the actual iPod. And so you need some of these techniques to help you deal with those situations. And really, it's then feeds into something like a search engine or your NLP system, et cetera, as kind of a baseline of pre-processing. But in that chapter, we also talk about how to give users things like auto suggest features. So if you start typing in a word, it will help you auto-complete that. That's a way of helping guide your users to good content that exists and will be helpful to them, as opposed to just letting them put in a mistyped word and then wondering why the results aren't any good.
But when I am thinking of using fuzzy string matching on single-purpose search engines, like those scientific research databases, I would expect the results to be sometimes weird or even wrong, especially if the system thinks I spelled this term wrong, but I actually didn't. How do you deal with those situations? Do these algorithms enable establishing feedback channels or other ways of adjusting the result set?
Yeah, no, that's a great question, and you're definitely right on. I mean, I think this is why it's called fuzzy string matching, right? Is there's inherently a score or a probability here that says here's the degree to which we think this is correct, and I always kind of have this saying. There's a reason why the saying is the numbers don't lie, not the text doesn't lie, because text lies all the time and users lie all the time. Not lie in necessarily a malicious way, but lie in the sense that they don't know how to spell, or maybe they do know how to spell, but you don't know how to spell, right? Or your algorithm doesn't know how to spell, or your data doesn't know how to spell. And so you always have this fuzziness factor going on in pretty much everything you do in this space, right? Whether it's search or machine learning, natural language processing. It's all essentially about coming up with a score, a degree of likelihood or a degree of relevance. And so I think the best systems are able to incorporate how users interact with that fuzziness in a way that helps them ultimately get to their answer, even if any individual answer is not correct, right? So if an engine just says, "Oh, here's your answer," and the user looks at it and says, "Sorry, no, it's not," then that application has failed. But if the application says, "Here's what we think is your answer, but perhaps here's some other suggestions, or here's some ways that you might refine your question," that usually is more successful. And of course, things like autocomplete also help preempt that, so that the user can see right off the bat as they're typing, and then adjust on the fly so that they get to what they're looking for faster. Because, like I said, at the end of the day, it's all up to that user to decide what's relevant and what's not.
If we go to the actually next chapter in your book after fuzzy string matching, I think there might be a connection between the two, since it is called identifying people, places, and things. I think that sometimes the two topics, fuzzy string matching and finding entities, can be in contrary to each other, because entity names tend to not look like the system thinks they should, don't they?
Yeah, I mean, so with this chapter, it's all about, identifying people, places, currencies, the things that I think we all inherently do or learn, when we learn, our native language or learn a language, right? You recognize the patterns that say, this is Tobias Kaatz, or this is IEEE, or this is LucidWorks, right? The indicators that lead to that. I think the challenge here again is how do I help find those things? Because, let's face it, like proper nouns and the like are often very useful for us as humans in understanding what a particular document is about. So if we know it mentions people or places or things, there's that familiarity with it, and there's that reasoning that we can do about it. And so I think it becomes really important to have tools that help you do those kinds of things. And obviously, the fuzziness here is often with the fact that, let's face it, most of us, are never mentioned in public content. So the odds of a computer or a learning model, a learning system ever seeing a particular mention of a person's name, especially if it's a non or a less common spelling, is pretty low, right? It's one thing to get Beyonce correct. It's another thing to get, Joe Smith or, whatever his name is, who lives, down the street from you, and you can never pronounce his name, right? So, so there is an inherent, again, fuzziness there. But thankfully, the languages do have some structure to them, and despite the fact that everybody calls it unstructured content, I think language is actually one of the most structured. It's just that we're not very good at teaching computers how to deal with that structure, and so we're often stuck, again, like you said, with these fuzzy states that we're in of, I think this is a proper name, but I'm not 100% certain, right?
Yeah, but going through your book, I still think that from this chapter on, you are talking about the more important but harder problems and challenges you have in actually understanding real text. It's not that you just understand a word and can say, okay, this is a proper noun or whatever, in a sentence in the biggest realm. You now want to get things in context and want to find out which is what entity is a place and how this relates to the rest of the text. So how do you face those challenges now that you can't really go to one word and tell what actually a role it plays in a sentence?
Yeah, no, that's that's definitely the challenge here. And this, I mean, frankly, this is what I love about this space and why it's so interesting and exciting because it is hard. The book, I think we definitely progress through, more or less how, things get harder as we go through the book. Ultimately, the second to last chapter is about actually building a fact-based question answering system. What you could kind of think of as a really lightweight version of IBM Watson or Google Now or Siri kind of functionality. And then, the last chapter actually is, hey, here's all the really hard stuff that, you could write a whole book on just those things as well. And we kind of left that as the sky's really the limit here when it comes to exploring these. I mean, I think we're seeing all the time systems are getting better and better at this. But there's still just a long way to go. And, like I said, this is where it gets really fun, right? Because, ultimately, if you're not working on hard problems, you're probably not going to be working very long, at least not in that field, right? And kind of the lower level functions are pretty well understood in terms of, an individual word. But, there's still even problems there. You've got things like character encodings, et cetera. But once we start moving up the stack there, if you will, to the semantic layer and the discourse layer and some of these higher levels of language where, there's a lot that's not said in a particular document or the way a user speaks that is either common knowledge or maybe is delivered sarcastically. So on paper or in a electronic form, that sarcasm doesn't necessarily come across. And so, those present really hard challenges for us as people trying to write computer programs that understand this kind of stuff.
That's right, but still really challenging for me to actually think about having things like QA machines or whatever. That's so cool to see what comes out of it right now.
Right, and if you think about it, as we're still kind of in its infancy. I mean, I think ultimately, QA is what people mostly want. Instead of having to sift through 10 blue links and that kind of stuff. They want, when they ask a question, they want what they think is an answer. But, that answer can be quite complex, right? It's one thing to say, who is the president of the United States right now, and answer that. It's another thing to ask the question, what are the reasons for the war in fill in the blank country, right? And to be able to ask that kind of question of a computer is really interesting as well. And it's also just frankly really hard to get back, a cogent answer there because, it involves so many complex ideas and different opinions and all of those things. And ultimately, that's what we as humans want to be able to do as well. But, let's face it, we can't get through all of the data there is to be able to always know the right answer.
What do you think IBM Watson, Siri, Google Now, you name it, is this approach scalable? So do you think that those engines will get better and better and better? Or do you think that we need to have a switch in technologies or switch in approaches to actually face the real challenges?
No, I mean, I think you see them getting better all the time. I mean, this is that whole collective intelligence approach to dealing with this kind of data, which is, again, we're making, educated guesses, if you will, based off of what other similar people did. Right. And then trying to overlay some personalization on it. I mean, I think they're great examples of the state of the art these days, and they are getting better and there will continue to be a lot of investment in those kinds of systems because, ultimately, I think what we are looking for is tools and approaches and things like that complement us. And take away the mundane tasks from us so that we can focus on the harder challenges et cetera, and ultimately make our lives easier, better, safer, more efficient, whatever kind of your personal goals are. So yeah, I think you're going to see continued evolution there. I don't know if it's really hard to predict revolution, so it may be the case that there will be one. 10 years ago, I think, Siri probably, or Google now, or Watson was really hard to obtain those kinds of results, whereas now it's, much more practical.
Yeah, definitely. Did you actually work on a system like that, or on QA systems? How did they look like, and what problem did they solve?
Yeah, so I worked on, back when I was at the Center for Natural Language Processing, we worked on a couple of different QA systems. I also worked on things like cross-language information retrieval and stuff like that. The book, the last example in there is a fairly basic QA system. It does reasonably well when you give it a good set of facts, and it pretty much is only targeted towards answering those facts. There's actually a lot of improvements that can be made to that. If you read like the Watson paper, a lot of the core foundation of what they're doing is similar to the approach that we're doing. Obviously, they're doing it at a much bigger scale and with a lot more data and more sophisticated algorithms. But the core of it, of taking a user's query, trying to figure out what that query is about, right? Or what that question is about. Is it looking for a person? Is it looking for a place? Is it looking for some particular answer type? Classifying that question into an answer type, and then using that to go do a search. And in fact, IBM Watson actually uses Lucene underneath the hood to do that initial passage retrieval. So that gives you a candidate set of documents that, the computer says, hey, I think one of these documents is going to answer this question. And then essentially doing that post, taking those passages and scoring them according to the likelihood, and kind of parsing those windows or those passages apart into an answer, is what is happening underneath the hood in Watson. Obviously, again, more sophisticated than what we do in the book, but in the book we provide a pretty simplistic approach to doing that, which works reasonably well. And then, you can immediately see all kinds of ways that you can improve it. So, I think then, one of the keys is taking that and having kind of feedback mechanisms built in such that you can learn as you go from, what's right and what's wrong. And if you look at the history of how Watson was developed and how Siri and Google now, they're constantly having those iterations of, hey, yes, the user liked this. No, the user didn't like this, right? And so that feedback loop is critical. And actually, to tie it back into your earlier question about how we learn, it's very similar, right? We get feedback from our parents, from our teachers, from books, from, whatever it is that, dispel or reinforce particular ideas and behaviors.
But then what is the difference between simply learning and artificial intelligence, like computers that think, in inverted commas, for themselves?
That's a great question. I mean, I think obviously the Turing test is one example there, which we talked about earlier. It's probably more of a philosophical discussion over beers as to whether a computer ever can, think or behave, and be human, if you will, if that's the ultimate goal, which, I personally don't care whether it is or not. I mean, I think it'd be interesting, but to me, I want systems that help complement, like I said earlier, what we're doing. Like I said, as far as whether there's true artificial intelligence someday or not, I guess that remains to be seen. My bet is that there will be, but I don't know when or where or how.
Although we have touched it a bit before, I would like to again discuss the last chapter of your book. One topic that stood out for me was understanding the meaning of bigger texts. Here you use the term discourse a lot. Could you please explain the term and why it is part of the bigger challenges in taming text?
Yeah, I mean, I think, when you start to talk about those higher level parts of language, you're looking at How do you incorporate world knowledge? How do you incorporate all of the things that are left unsaid or unwritten? How do you account for, the fact that I know some jargon and you don't, or vice versa? Or how do you account for the generation gap between people, right? So I think, trying to process and understand the meaning at that higher level can be really helpful for more effectively communicating as people, right? I mean, if you just think about how many things go wrong in this world by the fact that there's some gap or impedance mismatch or noise in the channel, if you will, between people, right? I mean, if you had ways to help smooth that over, help other people understand those gaps better, it seems to me, and it's obviously perhaps a little bit pie in the sky, but it seems to me that you have a real opportunity to help people, at the end of the day, get along better, right? But also understand each other better, and ultimately help the computers understand us better as well. And so, I think there's some really hard challenges there. Frankly, one of the reasons that's in that chapter of the Untamed section is there's just now starting to be some, work that is getting traction and helping computers understand those layers. And so you're starting to see some tools emerge there. I'm not intimately familiar with any of them, but I've, essentially seen some discussions on them. But it's a really hard problem. I mean, just think about two humans trying to do it, right? And how often we disagree, right? So if we can't agree, how would we expect a computer to agree when they're just doing essentially what we told them to do?
Yeah, everybody with a spouse can tell.
Exactly. Or kids or
yes.
or any of those.
Totally,
right?
totally. And one big gap is actually produced by people talking in different languages, and this is a challenge as well. Are there approaches to face that, and how is this done?
Yeah, I mean, there's that is it's one of the first problems I actually worked on in search, and it's kind of ironic because if you think about search as being a hard problem, cross-language search and cross-language understanding is even bigger, right? And so, short of getting everybody to speak the language, which, the fact that you're in Germany and I'm here and we're both speaking English is, obviously there's some level of effort happening that way, across the school systems and across the world. But also just being able to have better machine translation, all of those things are kind of underway, and there's efforts going on. Things like Google Translate. There's other engines out there that do similar things. So the approaches for this, obviously having people do it is really costly. It tends to be pretty highly accurate, but it doesn't scale very well. And so then you often look at how can computers supplement that. There are purely statistical approaches which just essentially take in two large bodies of parallel text. If you think about it, like for instance, the United Nations publishes all of its documents in, I don't even know how many different languages. And so those are effectively parallel texts, right? And so presumably you can line them up statistically speaking and figure out that, this phrase in German is so often correlates with a certain phrase in English. Right. And so then over time, you're learning those statistical patterns. There are also rule-based patterns, that say, if you ever see this kind of phrase in or sentence type or sentence structure in German, then that coincides with this kind of phrase in English or in Spanish or fill in the blank. And so, I think most systems kind of take a hybrid approach, which is they have some statistical models that they are grounded in and cover most of the language. And then they have rules that they overlay that deal with the exceptions, right? Because I think, like, especially in English, we have the saying, the exception that proves the rule, right? There's so many exceptions and irregular verbs and things like that give computers headaches, if you will.
Of course. Are there some scientific approaches on analyzing German as a language and to say then, okay, this is a proper noun in German, and then being able to map this on Spanish or Japanese, which would be really hard. Are there some approaches in this area as well?
Yeah, I mean, I think, this is where like a Google Translate approach is just, hey, let me look at, millions and millions of examples or thousands and thousands of examples, whatever it is. And so it's I guess scientifically speaking, it's a statistical approach, if you will. There's obviously linguists and people who study, do nothing but study a particular language or even a sub part of the language all day, every day. I'm not one of those people. But thankfully there are those people out there, so you can go to things like the Association for Computational Linguistics and the like, and really dig into those. And so there are people who are studying German as a language, and then of course they try to put it in the context of a common language that all linguists are studying, and so we try to map the concepts across those across the languages. But that's just one of the cool things about languages too, is there's often just some concepts that don't translate. And, I think ultimately that's what makes us human, but also ultimately what makes it even more difficult for the likes of us who are trying to, study this and make the computer understand this kind of stuff.
Yeah. Yeah. Getting a bit away from your book, I'd like to ask you if there is a feature or if there are features of Mahout, Solar, Lucene that are, in inverted commas, outstanding, because you chose them in the book, but even further, and it's outstanding, meaning without any equal feature in commercial projects or even Google. Is there something you can say, okay, use Solar because this and that, and you won't find it anywhere else?
Well, first off, I don't know what's going on in Google, so I obviously can't compare there. It's interesting. I think probably the most outstanding feature of all three of them is an intangible one, which is that they're community developed open source. And so not only is there code that, is held to a pretty high rigor, it may or may not be as good as, Google or Bing or the like. But, ultimately as an engineer, I can go look at it and I can dig into it. And I can decide that, hey, if I don't like that particular piece, but I like all the rest of this, I can change it. And so there's a really powerful community around all of those things. And one of the best things I say about Mahout is, regardless of whether you actually want to use our particular algorithms that we've implemented, there's a community there that is really interested in this stuff. And so if you just go and ask a question, chances are you'll find somebody who can help you. And sometimes we even tell them, hey, go use some other tool because we think it's better. And so I think that community aspect and the openness is probably the, without equal feature anywhere, just by, kind of by definition, right? As for, the technical features, it's been interesting in open source. I mean, I think, for a long time, open source was all about commoditizing commercial features. Whereas nowadays, I think you're seeing a lot of innovation happening in the open source. But again, I don't study every patent. I don't study every commercial project, so I don't know exactly what's going on. I do know, like in Lucene and Solar, we've done some really interesting things around compression and term representing the term dictionaries in an efficient way. We've been using things like finite state automaton and the like in really interesting ways to help solve search problems. I think we probably on the Solar side, we can probably scale more economically than anybody else, meaning that not only can we technically scale just to meet the demands of the amount of data you have, but you can actually afford to do that because you're not paying exorbitant licensing fees. So like I said, a lot of this comes down to a mixture of really strong technical features with this incredible openness model that ultimately leads to the sum of the parts being more than all the whole of the parts is worth more than the sum of them, right?
Ah, okay, I see.
I'm totally butchering that saying for some reason, but so like it's the combination of them over any one individual feature is probably where I would say is really the thing that stands out.
You said that, and I quote, we are good at and we have been doing good in this and that. How did you actually get involved in developing for those projects and starting Apache Mahout?
Yeah, that's funny. A little bit of a long story, but it won't go. I'll save a little bit. So with Lucene, I literally walked in the door at Center for Natural Language Processing. I'd been using open source for since I don't know 1999 or whatever. I walked in the door in 2004 with some people that I worked for before, but we had actually used a proprietary engine previously, and I was asked to implement an Arabic English cross language search engine. And I walked in the door, and my boss said, "We use Lucene. Go figure it out." I said, "Okay." And I started digging in and learning it. And as I was learning it, there were some things that I knew I needed to implement in my application that Lucene didn't do. And I got permission from my boss to implement those things, obviously, because I needed them. But not only did I get permission to implement them, I got permission to give them back to the community. And so, if nothing else, maybe perhaps it demystifies the open source process. But what happens is if you keep doing that, pretty soon the people who are responsible for the code base say, "Hey, we trust you," or they say, "Hey, I'm tired of reviewing your patches or your contributions. I trust what you're doing. I'm going to give you the rights to contribute those." And so that's how I got involved with Lucene. And then, interestingly enough, I think Mahout actually came out of Lucene. I had emailed, I think, I forget actually when, it was 2006, 2007. I had emailed the dev list one day and said, "Hey, this machine learning stuff is starting to heat up. I think it could be, there's a lot of interesting uses for it in the search space. Wouldn't it be great if the Lucene project had, a much broader scope beyond just search and actually took on and incorporated things like machine learning and natural language processing?" And I sent that email, and I think pretty much nobody responded. And then a year later, actually, this woman, Isabel Drost, actually a fellow German, emailed me and said, "Hey, are you still interested in this?" And I said, "Of course." And so her and I started emailing back and forth, and we started to kind of expand the net of people who we thought in the Lucene community would be interested in this. And out of it formed, essentially a small working group to kind of figure out what we should do. And at that same time, Andrew Ning, many people know from Coursera and the online machine learning course out of Stanford, had published, along with some of his students, a paper on 10 algorithms that you could implement, 10 machine learning algorithms that you could implement and MapReduce. And Hadoop was just starting to take off, and so we had read that paper, and we said, "Hey, wouldn't it be great if we started a project at Apache that solved, that implemented these algorithms, because these are kind of the tried and true machine learning algorithms." And away we went. The other need we had is a lot of the machine learning libraries at the time, we did not like their license on them. For better or for worse, we didn't feel they were licenses that our work would allow us to use. And so we wanted an Apache license project. We also wanted better documentation, and we wanted to build up a community around that code base. All things which, the Apache Software Foundation are very good at. And so we proposed this to the Lucene project management committee. They accepted. We started the project, and then I think about a year or two later, we actually spun it out as its own top-level project. And it is where it is now. There's pretty decent sized community there. There's a lot of interesting development work going on, and it's kind of taken on a life of its own.
Can you think of some topics that are actually open right now and you need help, and maybe our listeners can step in and help you out?
On the Mahout side, I mean, I think right now, what's happening in the community there, and to be honest, I'm not as involved in Mahout as I used to be, frankly, but I still do try to stay involved. Right now we're in the process of, a lot of the algorithms that we did originally were based off of Hadoop MapReduce. These algorithms are iterative by nature, and in the old way of doing MapReduce, that was very expensive. So there's been a real push as of late towards distributed approaches that aren't as iterative in nature, or at least better at dealing with iterative algorithms. So things like Spark, if you're familiar with that project and the like. We also have some effort underway in terms of just bringing in new approaches and calculations. So if you're a really hardcore, really good programmer, really good at math, et cetera, you can really get into the algorithms at a very deep level. And that's one way you can help on Mahout. But frankly, there's also just a real need for people who can do documentation, who can fix bugs, who can explain use cases, who can write examples, who can make it easier for people to get data in and out of the system. And so, there's lots of different ways you can contribute on Mahout. Same goes for Lucene and Solar. There's obviously core algorithms that are really interesting and often require, pretty deep knowledge around performance and quality. But there's just also a whole lot of low-hanging fruit in terms of bugs and use cases and examples and documentation. And so, one of the things I think I often find, people will ask me, how do I contribute to open source? And they have some bit of trepidation around it. And, I really encourage them to just start with something small and simple, get their feet wet, start asking questions, start answering questions. And then as you grow with the system, you'll feel more and more comfortable with it. And ultimately that can be a real boon to your career and your skills as a programmer.
Okay, so listeners, you're encouraged to go to the website of Mahout and Solar and Lucene and start working on it.
Yeah, and just ask on the mailing list too, hey, I've got some spare time, where can I help out? I think all of those pages, all of those websites have a how to contribute page on them. So if you just Google Solar, how to contribute, or Mahout, how to contribute, chances are the first link will be a page that says, hey, here's how you check out the code. Here's how you create patches or pull requests, or here's where we keep our documentation. Here's what we expect of you from unit tests. And so you can get lots of information that way. And it really isn't as scary as it sometimes sounds.
All right. My last question is, did we forget something? And we spoke about the second edition of your book. Is there something else in the pipeline? Are you speaking at conferences in the future? If people want to hear from you, hear you talk, see your work, where can they meet and how can they contact you?
Yeah, the hardest question of them all. What didn't you ask? I think we covered a lot of good things. I mean, I think looking at the upcoming edition, we're going to add in some new and interesting topics like sentiment analysis, summarization, visualization of text. So there's some really interesting things coming up.
Yes, very interesting topics, which is why I'm really looking forward to reading the second edition. All right. Since we reached the end of our episode, I want to say thanks for being on the show again and talking about your book, Taming Text. It has been a real pleasure.
Thank you, Tobias. Glad to be here again.
In addition to Grant, I want to thank you, listeners, for downloading this episode. We want to know what you think about this show and how we can improve. There are various ways of telling us. You can go to iTunes or our website and write a review of this episode or leave general comments. And I would encourage you to doing so. This is Tobias Kaatz for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To support us, you can advertise SE Radio by clicking the Dig, Reddit, Delicious, or /Thought buttons on the site, or by talking about us on Facebook, Twitter, or your own blog. If you have feedback specific to an episode, please use the commenting feature on the site so that other listeners can respond to your comments as well. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks again for your support.